In the dark heart of our galaxy lies a monster so powerful it bends space and time, and it's not alone. Today, we explore the secrets of black holes. Welcome to the channel. These mysterious phenomena have held our imagination captive for decades, fueling countless science fiction tales and stretching the limits of our scientific understanding. Prepare to have your mind expanded as we dive deep into the mesmerizing realm of black holes and begin to uncover the secrets they conceal. When black holes come up in conversation, most people tend to visualize a giant hole in space, a cosmic vacuum cleaner pulling in everything nearby. But that's a widely held misconception. Contrary to popular belief, black holes aren't just empty spaces. In fact, they're quite the opposite. They're the incredibly dense remnants of massive stars that collapse under their own gravity. This collapse is an extremely violent and dramatic event. Picture a star far larger than our sun running out of fuel and collapsing inward. This catastrophic end is what we call a supernova, one of the most powerful cosmic events. As the star collapses, its matter is packed into a tinier and tinier space. This compression becomes so intense that it creates what's known as a singularity, a point where gravity is overwhelmingly strong and no form of matter or even light can escape. That's what gives black holes their name. A black hole is essentially a region of space-time where the gravitational force is so immense that it distorts the very fabric of the universe. At the core of a black hole lies this singularity, a point where all its mass is concentrated. Think of it as a cosmic boundary where the known laws of physics no longer apply. It's a region of infinite density, a place so extreme that our current understanding simply breaks down. Just imagine compressing the mass of a massive star into something tinier than the tip of a pin. It's hard to grasp, right? This singularity is the beating heart of a black hole. The gravitational pull here is utterly overwhelming. Get too close, and you'd feel a force billions of times stronger than the gravity we experience from our own sun. This gravity is so powerful, it can bend light itself. And just when you thought black holes couldn't get any more bizarre, it turns out they come in different sizes. Black holes aren't all alike. We have stellar black holes, which form when massive stars go supernova. These are the most commonly found type, and they typically contain several times the mass of our sun. Then we've got the heavyweights, supermassive black holes. These cosmic giants are found at the center of galaxies, including our own Milky Way. We're talking millions, sometimes even billions of times the sun's mass, squeezed into a region roughly the size of our solar system. There's a theory that suggests even more massive black holes might exist. Primordial black holes, possibly formed in the earliest moments following the Big Bang. One of the most jaw-dropping consequences of Einstein's general theory of relativity is that gravity impacts the flow of time. That means the stronger the gravity, the slower time passes. Time itself isn't fixed, it's relative, and it can be altered by gravity. Near a black hole, where gravity is immensely strong, time slows down drastically. The closer you get, the more dramatic this effect becomes. This phenomenon is called gravitational time dilation, and it's one of the eeriest and most fascinating effects in our universe. Imagine traveling close to a black hole and surviving it somehow. Your experience of time would be wildly different from someone observing you from far away. You might feel like you spent just a few hours near the black hole, while the observer back on Earth sees years, even centuries, pass by. This phenomenon is well explained in the 2014 film Interstellar. Time itself gets stretched and compressed near such powerful gravitational sources. It sounds like science fiction, but it's a real proven consequence of Einstein's theory. What's even more mind-blowing is that this effect isn't just theoretical, it has real-world applications. For instance, GPS satellites orbiting Earth must account for gravitational time dilation in their systems to function correctly. Without making these adjustments, our navigation tech would become significantly inaccurate. Every black hole has a boundary known as the event horizon. It's the ultimate cosmic trapdoor. Once something crosses it, there's no going back. The gravitational pull becomes so strong that nothing, not even light, can escape. But here's the thing. The event horizon isn't a solid surface like a wall in space. It's a region where the escape velocity exceeds the speed of light. Imagine pointing a flashlight away from the black hole as you fall in. As you get closer to the event horizon, the light would stretch, its wavelength increasing until it becomes invisible. What lies beyond the event horizon remains one of the most enduring mysteries in physics. We can speculate, we can model, but we can never actually observe what's inside. It's a domain where our current understanding of the universe completely breaks down. Let's talk about a term that sounds ridiculous but is horrifyingly real: spaghettification. It's what happens when an object falls into a black hole. If you were to fall feet first, the gravitational force on your feet would be far greater than on your head. This difference, called a tidal force, would stretch you out into a long, thin strand like spaghetti. But it doesn't stop there. You'd also be compressed horizontally, making you into an extremely thin filament. This gruesome process is scientifically known as tidal disruption, and it's one of the more violent ends any object could meet in the universe. It's a haunting reminder of just how intense gravitational forces can be and how strange the universe truly is. When black holes collide, a cosmic symphony. Few things in the cosmos are as spectacular as the collision of two black holes. These events aren't just powerful, they're awe-inspiring showcases of the raw forces of nature. When two black holes spiral toward one another, they engage in a gravitational dance that distorts the very fabric of space and time. This cosmic ballet can go on for millions of years, with the black holes slowly drawing closer. As they do, they release staggering amounts of energy in the form of gravitational waves, ripples in space-time that travel at light speed. These waves were predicted by Einstein over 100 years ago. His equations suggested that accelerating massive objects could generate these waves. And in 2015, history was made when scientists detected them for the very first time using the Laser Interferometer Gravitational Wave Observatory, or LIGO. That groundbreaking discovery was the result of decades of scientific effort. Imagine it, we picked up the incredibly faint echoes of two black holes merging billions of light years away. These signals, though minuscule, carried the unmistakable fingerprint of a black hole merger. It confirmed a major piece of Einstein's theory and opened an entirely new way of observing the universe. These black hole collisions unleash more energy in a blink than all the stars in the observable universe emit combined. It's a cosmic concert of unimaginable scale and force. Every collision is a story of destruction, rebirth, and the relentless passage of cosmic time. Sagittarius A, the supermassive heart of our galaxy. You might be wondering, is there really a supermassive black hole at the center of our galaxy? The answer is absolutely yes. It's called Sagittarius A star, and it's a monstrous object, millions of times the mass of our sun, distorting space-time and anchoring the Milky Way. But don't panic. It's about 26,000 light years away, so we're in no danger of being pulled in. Astronomers have been studying this giant for decades, tracking the movements of nearby stars to measure its mass and influence. Sagittarius A star is a unique cosmic laboratory, a place where we can push our understanding of gravity and black hole physics. What's more, scientists believe that nearly every large galaxy in the universe has a supermassive black hole at its center, playing a crucial role in its evolution. And there you have it, a window into the staggering world of black holes. From time warps to spaghettification, these cosmic entities challenge everything we think we know about the universe. Drop a comment below, tell us which black hole fact blew your mind the most, and what other cosmic mysteries you'd like us to explore. Because in chasing the darkness, we find the light of understanding. If you enjoyed this dive into deep space, give the video a thumbs up, subscribe for more cosmic content, and tap the notification bell so you never miss an episode.